In today's notes, we're going to be talking about describing transformations. And most of the time, more than one transformation has occurred. So I'm going to do two examples, and I will follow the steps on the left-hand side to sort of test and see what has happened to the image and the pre-image. So I know that A is my pre-image, so the first image, and that B is my image or the second image. And I know that because A comes first in the alphabet, B comes second. When I'm looking at these two triangles, I can tell that they're not being slid. Like A has not slid over to become B. It looks as though there's been a reflection. And I can sort of just see that in my mind's eye. So I go over to step one. I indeed think there's been a reflection. And it looks as though it is reflected across what seems to be the y-axis. So I'm going to go ahead and go with it's reflected across the y-axis. So I'm going to reflect it and see where it lands. So each vertex is going to be counted from left to right. So this point is 3 away, so we're going to go 3 in the opposite direction. This point is 9 away, so I'm going to go 9 in the opposite direction. And then this top vertex is 8 away. I see it lines up with 8 on the x-axis, so I'm going to go 8 in the opposite direction. And I'm going to draw my image. So I've reflected it across the y-axis. Now I'm going to figure out how it moved from this image to B. Every vertex is lining up currently with the vertex of this other triangle. So I'm just going to say that it's shifted down 2. Each one has gone down 2. So from here to here, that is 2, 2, and 2. So there's been no rotation, but there has been a translation, and I believe in my description I'm going to list both of those things. I'm going to use this empty quadrant since there's a lot of space here. My first transformation was a reflection across the y-axis. And my second transformation was a translation 2 units down. And I'm also going to write it in this form, this notation. So in this notation it would be x by itself because it didn't move horizontally at all, but it did go down, so that's a y movement, and a down means a minus 2. And I'm just going to add that in there because I know these two things mean the same thing. Now, I want to point out that you also could have reflected the image across a different thing. So you don't need to write this down. I just sort of want to demonstrate how the answers could have changed. Let's say you chose a different line. You could have absolutely chosen x equals -3, for example. Across x equals -3, so if I did that, this point would stay where it is. This point is 5 away, 1, 2, 3, 4, 5, so 1, 2, 3, 4, 5. And this is 6 away, so 1, 2, 3, 4, 5, 6. So now I have reflected the pre-image over x equals -3. Now, clearly there's still been a transformation. This transformation I'm going to map from the top vertex, so over and down. So in this case, if I reflected it over x equals -3, then the translation would have been right, 1, 2, 3, 4, 5, 6. So x plus 6, right? And 1, 2 down. So y minus 2. So in this case, I would have said, okay, reflection across x equals -3, and translation 6 units right and 2 units down. And you could have also used this notation, x plus 6, y minus 2. So this is just another way we could have seen the reflection happening if we had changed the reflection line. So there's a lot of variability, there's a lot of flexibility in how you can see things changing. So just keep that in mind. Now the next one we're going to do is this guy. I'm going to outline it so it's a little bit darker. This is my pre-image because there is no apostrophe, therefore this is my image because there is apostrophes. Okay, so this one, definitely not seeing a reflection. It's not looking like it reflected over the y-axis. It definitely looks like it's been turned though, which makes me think of a rotation. So if it did rotate, I want to think about how it could have done that. So if we went counterclockwise, that would have been 270 degrees. If we went clockwise, if we went clockwise 270, counterclockwise would have been 90. So I'm just going to go with 90 counterclockwise. So I'm going to imagine that it moved this way, 90 degrees. So I'm going to test this and see if it works. So I'm going to turn my paper one time in this direction. Now I'm seeing that this is my new y-axis and this is my new x-axis. This is positive, negative, negative, positive. So C would be at positive 5, negative 3. Okay, before I do any more work, I'm going to spin it back and see if that's where C actually is. So if I look at C, C is at positive 3, negative 1. So that is not working. So this is not going to be a rotation in that direction. Let's see if it's a rotation 270 degrees in the clockwise direction. So I'm going to spin it 1, 2, 3. And again, you're going to see we're going to line up with the exact same thing, 5, negative 3. So it's not a rotation. I've tested it. It's not a rotation. Not yet, at least. So I'm going to think outside of the box. What if my image reflected across the y-axis? If we reflected it across the y-axis, it would leave us with C here. So that'd be C prime. B is 7 away, so I'm going to go 7 in the opposite direction. And A is over here. So this is where my new triangle is. Okay, so now we're getting a little bit closer because I'm already seeing that after reflecting it across the y-axis, I'm just going to go over here and say we reflected it across the y-axis, that I could also reflect my image again across this line. I remember doing this in reflections last week. So if we reflected across this line, which is y equals negative 3, you would see that C is 2 away. So C prime and C double prime are 2 away from this line. B prime and B double prime are both 1, 2 boxes away from the line, 1, 2 boxes. And A is 1 below, and this A is 1 above. So we could say that this image reflected first across the y-axis, and then again a reflection across y equals negative 3. There's probably another way we could have gotten to this image, but this is what made sense to me. These two reflections were the first thing that my brain saw. It's totally fine if you see something else as long as it works. It could also take you more than 2 tries to get to an image. It could take you 3 tries. Maybe you reflect it across the x-axis, then again over the y-axis, then again over the x-axis. You rotate it, you translate it. You just have to figure out what works.